Hi all, and welcome to the final presentation and demo of our project for deep learning and convolutional neural networks. I am joined by my colleague Michael, who will provide a demonstration of the working application and an overview of how we utilized AI within a mobile Android application and GUI. I will be providing an overview of the project and of the subsequent development and exploration of the model. The premise of the project is simple. As the coronavirus locked down people worldwide, there was an explosion in the number of households purchasing or adopting dogs. RSPCA warned that dog adoption was not an impulse buy, it's a life commitment, and subsequently it must be done with the utmost consideration for both the animal and the owner's needs. There are hundreds of dogs, and for many individuals they cannot even name a quarter of them, let alone have an understanding of each of these breeds' unique and specific characteristics, medical and physical needs. To assist consumers make the appropriate and informed choice, we have developed an AI that will assist the consumer to pinpoint a dog's breed and be able to provide specific and informative information pertaining to the relevant dog to assist households in their search for a suitable dog. Beyond this use case, we see this application being utilized to identify the breeds of lost dogs that have been located, and in the future, assist veterinarians with initial health screening. We utilized the Stanford Dogs dataset within the development of the AI, creating a training, testing, and validation set to split the model for use within the experimentation of alternative architectures to identify the optimal architecture for implementation within the final application. We tested 3 alternative CNN architectures, experimenting to find the optimal combination of fine-tuning and hyperparameters to maximize performance, including Inception v3, ResNet, and VG16. Each model worked with various levels of success, and ultimately we found Inception v3 to provide the best combination of speed and performance of around 80%. When integrating the model into the application, we ran into issues surrounding the implementation of on-app image analysis to allow for efficient classification of dog images. We utilized TensorFlow's TF-Lite framework to allow for this. Unfortunately, the conversion of our Keras model into the TF-Lite format resulted in issues on the mobile side. To provide a seamless proof of concept regarding the integration of model and application, we trained an additional model utilizing TensorFlow's TF-Lite model building framework on a subset of the Stanford Dogs dataset to provide a model that demonstrates the vision of the application and the integration of the two systems. The TF-Lite model utilizes the baseline efficient net B0 to provide a baseline and ultimately performs quickly and provides a good test of accuracy at around 70%. It is expected that with more mobile development knowledge and the time, the integration of the Inception v3 model may be implemented within the application to further improve the performance of the app.
Hello, my name is Michael and I'll be presenting the designs and features of our application. Our application is mobile-based and currently designed specifically for Android-capable devices. It makes use of the back camera of the mobile phone to acquire data and send image data to our installed model. This was selected as our method of implementation of our model since it's easy to use and can be reasonably used on the go, unlike desktop-based applications. This is perfect for outdoor settings, which is where the user of the application most likely come in contact with the dog. There are 2 main pages in the current iteration of our mobile application. The first image on the left is the application's landing page, which is dedicated to 2 main tasks: the presentation of the camera image, as well as the results from the output of our model. The output displays the 3 most likely dog breeds contained within the image. Each label is clickable and will display the relevant information about that dog breed. This method was chosen as the desired method of communicating the output since it is unreasonable to train a model on all crossbreeds according to our topic. If we had 1 crossbreed between each dog breed, the dataset will increase greatly in size and scope. And with each crossbreed bearing similar features to the parent breed, it would lose overall accuracy since it would have strong correlation to other classes of dog breed. This is especially troublesome for our large dataset of 120 dogs. As such, having 3 breeds displayed allows the user to see what other possibilities of dog breed for the dog in front of them. For example, if a crossbreed of A and B was seen, the model will be able to detect features from both and would display both dog breeds as a possible result. This solves our problem without needing large datasets and complex models that would perform more slowly in this environment. The second page is our information page, which displays the dog breed information and information regarding that dog breed. This page is currently a proof of concept for what our final application entails, since we lack the market research and professional software design to properly design this page. But all information held on this page relates to what information a new buyer will be interested in, such as the size of the dog, the difficulty to raise, and what size home is recommended for the dog, such as apartment, complex, or farm. All information on this page should be either visual or simple, as the information needs to be easily understood and conveyed in a meaningful way. By also providing levels and graphs, it helps the user compare the statistics of dogs against other breeds to better understand what their purchase entails. I will now move on to the live demo of our application. The emulation is a lot weaker than an actual mobile device, and the quality of the image as well as the stability of the image will be much easier to capture when you're holding it in your hand as a device instead of trying to do the process of trying to hold the image yourself. So on the next part of this is the three labels that we see here. If we click one of the labels, it will take us to the information page regarding that label. As we can see, the device is able to capture what label we pressed, what dog breed, which is important, so it provides the correct information, and some of the information that we believed was important when considering what information a user who is purchasing the dog for the first time might want to consider, such as difficulty, the cost, the size of the house that it occupies, the length of the hair for those with allergies, whether or not the dog is child-friendly. These are some of the information we believe to be important, but there could most likely be others that we haven't considered due to the lack of market research in this area. We can return to the main page using the phone's hardware and return to the camera. And then we can click on a different dog breed. French Bulldog. And we see that changes. Currently the information that is shown isn't meaningful as we didn't put any research into the actual dog breeds themselves, since it's outside our field of expertise and we would only offer superficial or incorrect information on the matter. So right now the information is randomized. However, in future releases or public releases, this information will be correctly presented to the public. And this page would have a lot more development when software designers who have expertise in, say, graphics designs, more experience in how to design various visual assets to convey the information. This is important in the future of this application. This concludes the live demonstration of our demo, and I hope you enjoyed our dog crossbreed verification application. Thank you.